Hello, this is Mr. Stansbury. I'm going to take you through the notes on conditional probability. At the end of this, you should be able to say, I understand and can apply the conditional probability formula to find the probabilities of various scenarios. Okay, so first thing, the conditional probability of an event B is the probability that the event will occur given the knowledge that event A has already occurred. Okay, so this is written as P, probability of B, given that A happened. Okay, I'm going to take you through some examples here, but I'm going to explain this formula here first to you. So here's what it looks like, probability B given A. So that's going to be the probability, easiest way to look at this is probability of A. So you're only choosing from this this group A here. So we'll call this as A, and this is also A. So you're only choosing from this group A, and what's the probability that from that group A, B also happened? That's what this is saying. Probability of B happening given that A already did happen. Okay, so let's look at some examples, and that will should help clarify. Okay, so let's take a look at example 21 here. It says, in Shamrock, Texas, 77% of the residents own sandwich sandals, 62% own fish flops, and 13 don't own either. Draw a Venn diagram to describe the situation. Okay, so let's see. Let's go with sandwich sandals over here and fish flops over here. So we know 77% own sandwich sandals, 62% own fish flops, and 13% don't own either. Okay, now this should be, since we're talking about percentages, this whole thing should add up to 100, right? So to figure out what we got going on here, we know that 100 minus 13 gives us 87. So we know these three areas have to add up to 87. Right now, if we take 77 and 62, we add those together and we get 139, which is way too big. So we take our 139, subtract 87 to find out how many things got counted twice, and 52% of the people own both fish flops and which one? The sandwich sandals, that's what it's called. Okay, so if there's 52 here, now what we want to do is we're going to take 77 minus 52, and that gives us 25. So there's 25 that own just the sandwich sandals. And if we do 62 minus 52, that gives us 10 that own just the fish flops. Okay, so we have A drawn the diagram. Find the probability that a randomly selected resident owns both. So that's here in the middle, that's 52%. How about owns only fish flops? That would be 10%, because that's just the fish flops over here. Owns sandwich sandals, given that they own fish flops. So the given that is what we want to start with. So given that they own fish flops, how many people own fish flops? For number 3 here, that is going to be there's 62 total people that own fish flops. In fact, let's do this. That's the given that. That's our denominator. And then how many of those also own, of these 62 people in this circle, how many of them also own, let's see, how many also own the sandwich sandals, which would be 52. So 52 out of 62 will tell us our percent on that. So we do 52 divided by 62, and we get 83.9% if we round it off to the nearest tenth. So we get 83.9%. Is that right? Yep, 83.9. And then doesn't own fish flops, given that they own sandwich sandals. So sandwich sandals for number 4, that is going to be, sandwich sandals is 77 total. And how many don't own fish flops, given now that they own sandwich sandals? I'm going to circle this in a different color here. So there's our sandwich sandal people, right? That's our 77 people. Now, how many, given that, how many do not own fish flops? So that's these 25 over here. So we get 25 out of 77 And that's going to give us our percent for that one. So 25 divided by 77 gives us 32.5% if we round it off. 32.5%. Okay? All right, we're going to do one more example here, but let's take a quick comedy break first. All right?
She gives him the phone. He has no idea there's a camera in there. He's just whipping it all over the place. I'm seeing his face zip by at the speed of light. I'm yelling, "Stop moving the phones! Aim it in one place!" He thinks it's for audio reasons. He aims it at the corner of his room. I'm seeing a cobweb dangling. "Can you hear me?" "I always could hear you. Aim it at your face, Dad." So he sort of gets it, but not really. It's like two unfocused eyes. They don't know where to look. Like an alligator coming out of a swamp at a 45-degree angle. I'm like, "Hey, Dad, how you doing?" "Who is this?" "It's Brian." "Who am I talking to?" I felt bad until he asked, "Who's that in the square up in the corner?" "That's you, Dad." "No, there's somebody in the corner looking at us."
Okay, let's take a look at the last example. Example 22. Elise has two shelves with Pringles on them. The top shelf has 5 paprika-flavored Pringle cans and 3 ketchup-flavored Pringle cans. On the bottom shelf, she has 3 paprika cans and 7 ketchup cans. Elise is 3 times more likely to take a can from the top shelf. If Elise takes a can at random, find the probability that it is paprika flavored or was taken from the bottom shelf, given that it's ketchup flavored. Okay, so made a tree diagram just to kind of help figure this out, make it a little bit easier. So it says she has, let's see, 3 times. She's 3 times more likely to take a can from the top shelf. So that means 3 out of 4 times she's going to reach from the top shelf. And only 1 out of 4 times she's going to reach from the bottom shelf, because 3 times. So if she chooses 4 times, 3 of those 4 times from the top, one of the 4 from the bottom, right? On the top shelf, there are, let's see, 5 paprika, and there are 3 ketchup flavored. So there's 5 out of 8 is paprika, 3 out of 8 is ketchup. And on the bottom shelf, let's see. Bottom shelf, she has 3 paprika cans and 7 ketchup cans. So 3 and 7 for a total of 10 each. 10 on the bottom shelf. Okay, so now we've got this all set up. Should make these questions significantly easier. So if she chooses, Elise takes a can at random, find the probability that is paprika flavored. Okay. So that means it could be the top shelf paprika or it could be the bottom shelf paprika. So it could be either one of these, right? So that's going to be 3/4 times 5/8. And then also it could be 1/4 times 3/10. Okay? Okay. So calculated these out. And we get 46.9% for taking a paprika flavored can from the top shelf and 7.5% from getting a paprika can on the bottom shelf. So if we add those two together, 46.9% plus 7.5%, that's going to give us 54.4% chance. Okay? Now, part B says, find the probability that it was taken from the bottom shelf, given that it's ketchup flavored. So now we're only talking about, we know for sure that it was ketchup flavored. So it's this one and this one. Okay, so we got to figure out those two. Okay, now here's the key. Look, we already figured out these two. All 4 of these always have to add up to 100%. So we already got 54.4. So let's do 100 minus 54.4, right? So 100 minus 54.4 gives us 45.6%. So we know that there's only a 45.6% chance of taking it from the bottom shelf. So what? Oh, sorry, of taking a ketchup flavored can. So what's the probability that it was from the bottom shelf? So that would be this one here. So that would be the 1/4 times 7/10, right? Which is 7/40. So if we do that one, 7/40, we get 17.5. Right, so we would need to take 17.5 and divide it by 45.6. So take that divided by 45.6, and we get, oh, rats, I did that wrong. So let's do 17.5 divided by 45.6. There we go. That'll give us a little bit better answer. 38.4%. 38.4% chance that the randomly selected can was taken from the bottom shelf, given that it was ketchup flavored. Okay? All right. That's all there is for conditional probability. If you have any further questions, please feel free to ask in class. Thanks.